Hello, today we're in search of a Hexify function and hopefully we can find it using a focused approach. So the first thing I'm going to do is a quick overview of the problem statement for Hexify, and then I'm going to have a little discussion about how to focus on the right things and how to avoid looking at too many things at the same time. So that's going to be perhaps a challenge of your belief system, but I'd like to do that. And then after that, I'd like to show you how to write the Hexify function based on that technique of focusing on two functions, the bit and the bit shift, and how to take the bitify 8 function and transition it to a Hexify function. So the Hexify function, what that is you're looking to have two inputs, a signed value that you're going to hexify, and what that means is you're going to find the hexadecimal digits for a particular value, and the other input is a number of bits. A number of bits could be 8, 16, 32, or 64, depending on how many bits that value is coming in. The important thing is that the value is signed. And we're going to output a character vector, so that's going to be a character representation of the hex digits that are coming in on the value. And an important thing that jumps out to me is using the functions bit shift, bit and bit complement. So those functions we'll sort of investigate. Another thing that jumps out at me is there are 4 bits per nibble. So if I have 8 bits, that means I'm going to have 2 nibbles. And if I were to look at 8-bit examples that were given, if I hexify the value 1 at 8 bits, and that's going to give the result hex 0, 1. If I also think about what the binary equivalent of that would be, of course it's just a 1, so hex-wise is 0, 1. Binary-wise, only the 1's place is on. The 2's, 4's, etc., all those are off. So seeing this connectivity that this 1 is coming from that low nibble, the low 4 bits, and that 0 there is coming from the high nibble or the high 4 0 bits. That's important to make that connection that there's a nexus between 1, the binary representation, and the hex representation. If I look at the 127 from a binary perspective, I know that I'm going to have all bits on up to the 128 place. The 128 place is off, but the 1's place is on, 2, 4, 8, 16, 32, and 64. All those are on. And I'm going to get a 7F out of that, and that means that the low 4 bits are all on. That's 15, and the upper nibble is going to have a 7. It's going to be equivalent to a 7, which I see from a binary perspective quite nicely here. 1, a 2, and a 4. Again, there is that nexus between the value that comes in and the binary representation of it, as well as the hexadecimal representation of it. Boy, if I could go nibble by nibble and sort of pick this incoming value apart, nibble by nibble, wow, if I could just figure out nibble by nibble, what is the value of a particular nibble, and I could just index into this lookup array and grab the character value right away. So that is kind of telling me that right here in the problem statement. What I like to do is a focus study. I like to build on valued work and try to narrow a focus on a few technically correct things. I want to have a goal of what I'm trying to achieve, and I sort of picked apart some cues in the problem statement that I showed you earlier, and I tried to take things in the book, videos, lectures. I had some example code that I showed you, and what I try to do is connect the dots. Are there seeds that are planted in the things that I've seen that would sort of kick me forward and get me towards my goal? So that's a focused approach that you would use. That's really ideal. An unfocused study is where you immediately broaden your search envelope. You search the universe, and you're searching for a fully complete answer to whatever the current problem is. And it's sort of is not a great way to go. It can be overwhelming, and what you might do is you might not look at the book, or you might skim the book. That's not ideal. The videos, maybe you don't watch them. Maybe you watch them at a faster speed. Lectures, maybe your mind is wandering of what you're going to do after the session. Those kinds of things. So you're not setting yourself up for success. That's sort of unfocused. And immediately jump into Google. I did this little exercise here. Hey, if I search for print hex in MATLAB, I'm getting a lot of results. I'm getting almost 1 million results, and just navigating that, that can be very daunting and very unfocused. If I look at all of the MATLAB functions that are available, my gosh, that is also overwhelming. I'm looking at 18,000 possible functions. So that, again, overwhelming. And if I focus on the group me, I'm relying on other people who don't really know what to do as well. Commiserate with them is all I can do. Anyway, so let's say that you are lucky enough to find a completed answer to the current problem. Well, you know what? You're not vested. You're going to forget the details of whatever the solution is for that particular problem. You're going to forget that very quickly. You're going to have to reinvent whatever fortunate search sequence you had if you need this thing later. And an important last note that I want to make is this doesn't really make you better for adapting to different challenges that you have later. So what I like to do is to emphasize, hey, focus on some things that you're given and expand from that. Use the instructor, use the TAs, rely on them to help you connect the dots. So this one thing here, you need to do that. You need to invest yourself into do that. And this thing you're cultivating. So I don't know how else to explain it, but there is a brain muscle that you have that you rely on to sort of connect dots. And if you do that, if you put effort into that aspect of it, then in sort of cultivating that capability, then you will remember. You will remember what you did to get the Hexify function, and you'll be able to kind of adapt it to different changes. So you take, cultivating means connecting those manageable dots. That makes you better, and it empowers you to do a similar dot connection next time. Maybe there's a slightly different problem, but relies on the bit and bit shift, and boy, you'll be able to do it if you really understand those functions. In the original problem statement, the bit shift and the bit and, those actually jumped out at me, and this leads me right to the Bitify 8. The Bitify 8, what it does is it takes a value and it outputs a binary bitwise character string, and it does it using the bit and the bit shift. For getting help on bit and, I can do this right here from a command prompt, and I can simply digest what this is telling me. It does a bitwise and of the A and the B, and then there's a version where you do an assumed type, and that's something I rely on. But you can certainly digest that. It's very manageable. And then there's a bit shift as well, help bit shift, and that takes it shifts the value A by k bits, either left, shifts left if k is positive, it shifts right if k is negative, and there's also an assumed type. But at the end of the day, it's very manageable to sort of digest the documentation you have for that. Even in this current presentation, initially I looked at an example of 1 and the hex 1 equivalent and the binary 1 equivalent. And then I also looked at 127, the 7 Foxtrot hex equivalent, and then the binary equivalent of that. These are kind of the extreme. This is the most simplistic, perhaps, and this is an extreme value. So I thought I would take a look at a simple value. That's kind of my thought is let me nominally look at a simple but not too simple. Example, and something that's not complex. So I thought I'd look at a 13, for example, and see that hex-wise, this is 0D. And I know it's 0D because the binary equivalent looks like this, and the upper nibble is 0, and the lower nibble is 13, or D. Okay, the Bitify function was actually given to you in class, and here I'm just thinking out loud that maybe I try to Bitify 8 and I give it a value of 1, see what happens. Yeah, it's not giving me the leading 0B, but it is giving me 8 character bits. It's giving me 7 leading zeros, and then the 1 is expected. And if I were to try Bitify 8 of 127, yes, it is giving me those lower 7 as 1, as I was thinking, as I showed you before. And that highest bit is 0, as anticipated. Now I want to try the Bitify 8 of 13. And yes, it does give me the high nibble as 0, and then the low nibble is 13. It shows me as binary, and I speak to you as I see it, kind of collecting those bits or those nibbles as I see them. So here, I've shown my Bitify function in the background, and I kind of want to step through logically what's happening, and I'm just going to set my value as 13. All right, so I'm coming in with a value of 13, and I'm just going to think about, well, what's happening on this very first entry here. And I'm going to be doing a bitwise AND, but I'm going to show right here, Bitify 8 of value. See what that looks like. And again, it's that 0D. I'm doing a bitwise AND of value and 1. Well, what does Bitify, remember what Bitify 8 of 1 is? Well, that's 1. So if I look at a bitwise AND of those two values, value 1, that's what this is saying, bit AND of value and 1. And I'm going to do a 1 and a 1. That's going to be 1. And if I do bitwise of any other bit, that slot is going to be 0 because this is dominating. That's 0 means it doesn't matter what anything is up here, because that is 0, it's going to be 0. So in my previous lecture, I actually called it a mask. So this Bitify 8, when I do a bitwise AND of value in 1, I'm really just masking off that lowest bit of the value. Now, let me do it. Bit AND of value in 1. Let's see what that looks like. It's just 1, and I mean it's pretty straightforward. You're just doing a bitwise AND of this value, which is this, and 1, which is that. You're just going to be able to get that last bit, and the last bit is just 1. So that statement is going to assign the character, because that's going to be true, it's going to assign the character 1 to this first slot in the string reverse. The rev means reverse. String reverse, that first slot of the character vector. It's going to put 1 in that slot. And then after this is done, I'm going to bit shift value 1 place to the right. So let's do that. I'm going to say value equals bit shift value, and then I'm going to say to the right, so that's a -1, and that's going to be, and then I'm treating it as an int 64. Come back to that in a second. And it looks like a 6. Now, when I do Bitify 8 of value, see what that looks like. Yeah, so it's changed from what was 13 before. Now it's just 6 because a 0 came in on the left, and the 1 that was there before is sort of dropped off. So now, when I do a bitwise AND of the current value in 1, I'm going to get a 0. So the next time through, that 0 is going to be true. It's going to be assigned to II of being of 2. Okay, and then and I could do it right here. I could say bit AND of value in 1. it's going to be a 0. And then I can say value equals bit shift value and minus 1. 64, I'll just add that as baggage. And now it's a 3. Because what's happened is, what I had before being a 6, that 0's dropped off and another 0's come in on the left. Bitify 8 value. Right now, it's dropped off there. I've lost 2 bits from the 13 I had originally. Now, when I do the bit and of the current value, I'm going to get a 1 and I'm going to get another 1. So on the next one after, and you know, I can actually show this if I turn debug on. Clear command. Here's what I'm going to do. I'm going to say global debug, and then I'm going to say debug equals true. And what I want to do is, so debug is true, so I should be printing out this statement. And this statement's going to say, okay, what is II? What is the current string rev for that particular status with that particular II, whatever we are. And then it's also going to show the value. So let's see what that looks like. So I'm going to say bitify 8 of 13. See what happens. Oh yeah, so this is, you know, why you can do debug, because you can see the progression of how the digits, the binary digits, are appended to what you had previously. You can see that the 13 on the first, after the first shift has gone to 6, after the second shift has gone to 3, and after the third shift has gone to 1. And then, you know, after that, there's just zeros. So you're always going to have 0 after you've shifted off all of the lower 4 bits. And the string rev is kind of assembled in the reverse order. So I've got the least significant bit on the left and the most significant bit on the right. So I really want to reverse that, and that's what's going on down here. I just simply reverse it. And that's how Bitify works. It's pretty straightforward. So what I'd like to do next is to make this a little bit more mature and add in a lookup. So I've got a 2-element lookup vector, and I've made it persistent. And here what I'll do is, instead of doing this if, I'll just say cur bit equals bit and a value and 1. And I'm going to do this. Okay. And then I'm going to assign to string rev, I'm going to use the cur bit. So the value of cur bit, the possibilities are 0 and 1. That's the only possibilities because of what that is right there. That's a 1. So the only output I could get by bitwise anding anything with 1, the only value I can get is 0 or 1. So cur bit is going to be 0 or 1. So I'm going to use that to dial into the lookup cur bit. But remember, the way I can't do it like that because MATLAB uses starts their indices at 1, so that's going to be 1 or 2. So what I need to do really is to add a 1 there. So whatever cur bit is, if cur bit is 0, then that means I'm 0 here. That means I'm going to be pulling the first element out of that, and I do. I want that 0. And on the other hand, if cur bit is 1, then that means cur bit is 1, 1 plus 1 is 2, and I'd be pulling that element there out of the lookup, and that's exactly what I want. So I'm going to save that and come back and run Bitify 8 with the new code as 13, and yea, verily, I get the correct answer there using the lookup technique. Okay, what I'd like to do now is to transition this Bitify 8 into maybe Hexify 8. So for that, what I want to do is I want to focus in on this bit and. I want to do a bit and of value, and I want to pull off 4 bits. This is only doing the 1 with the Bitify, I want to pull off 4 bits. I'm going to change that to a 15. 15 is what I would need to mask off the lower 4 bits, whatever's coming in of value. Let's go take a look at what I mean. So if I were to say value again equals 13, for example, and then remember if I do bitify 8 of 13, I get that. So let me do a bitify 8 of 15, see what I'm talking about. So when I do bitify 8 of 15, I'm going to have those lower 4 bits all on and the upper 4 bits all off. And when I do a bit and of the 13, which is value, and bitify of 15, I'm going to get 1 and 1 is going to be a 1, 0 and 1 is going to be a 0, 1 and 1 is going to be a 1, and 1 and 1 is going to be a 1. Basically, I get whatever I had for the lower 4 bits because it's going to mask them off. That's the whole point. You're masking off those lower 4 bits, and it doesn't matter what these upper 4 bits are because, again, these the upper bits here are 0. So the whole purpose here is to mask off what those lower 4 bits are looking like. Now when I do bit and of value and 15, and I'm going to add in that int 64 thing, baggage, see what happens. Yeah, I get 13, which is what I said. Okay, so I'm going to mask off the lower 4 bits as I discussed. And here, the result of the bit and here, I just showed you it was 13. And the possibilities here for bit and, after I do this, masking off bit, I'm going to call that variable, the resultant variable, I'm going to call that cur nibble. Because the cur nibble is going to be a value. And it's going to be 0 to 15. So now, instead of doing the simple thing I did before, I could do something really ugly. If cur nibble equals 0, then string rev, I mean, I could literally do something pretty ugly like this. Else if cur nibble equals 1, then I could do that. Else if cur nibble equals 2, do this, and so forth. And I'm just going to skip a whole bunch. I think you maybe get the idea. Else if cur nibble equals 14, then here that would be E. Else if cur nibble equals 15, then that's where you'd finally get the F, and then you would end it. So that's one way, one ugly, grotesque, ugly way of doing it. So what I had set before was to use a lookup table or an array, and I actually gave that something for you, and I'd like to make it a persistent, so it's a variable that is sort of hidden in the background for you, but there all the time if you need it. And what I'd like to do is to assign string rev something related to the cur nibble looking into that lookup. And so I'm going to use cur nibble here. So remember, cur nibble is between 0 and 15, but doggone it, the lookup here is going to, the index is going to start from 1 and go to 16. So I have to do that plus 1 just like I did in the bitify lookup. So just kind of rechecking myself. Cur nibble goes from 0, and if it is 0, then I'd be looking up 1, and that would be the 0 character I want. Or if cur nibble is 15, in other words, all the bits are on for that particular nibble. If it's 15, then I'm going to be looking up 16 here and pulling off F. So yeah, that's going to work. That's going to work nicely. And then sort of the last statement here of the loop, forgetting the debug for a moment, but the last statement of the loop is going to be a bit shift. I want to make this -4. So I'm shifting 4 bits to the right so that the next time through the loop, I'm going to get the next higher nibble, all 4 bits that I want. And my II here for an 8-bit, I'm only going to be doing 2 nibbles there, so I need to change that. Okay, and then here, same thing. I need to go to 2, and my string rev is only going to be 2, so I'm going to be reversing the 2 that I get out of this. So I've only got 2 nibbles to sort of contend with. And how do I want to do this? I think I want to say string equals OX concatenated with string, because I want to give that little preceding OX. This might work. Yikes, let me save this. Save as Hexify 8.m. Okay. All right, let's try it. So I come over here, clear command, Hexify 8 of 13. What do we get? OXOD. Oh, that's perfect. Okay, I'm in a really good place right now. And what I thought I would do is sort of go back through and make sure I'm meeting the requirements. So I could say Hexify 8, put some comments in here. Accepts value and returns a string of hex digits. Okay, so input is value. Output is a string with a leading OX. String with leading OX that gives the hex value. And I can say local variables. Let's see, II is a local. II, a counter is a global that controls debug info. Let's see, cur nibble is the current nibble being sought. String rev is the reversed equivalent of the returned string. What else we got? And lookup is a persistent array of hex digits. Okay, so that's one thing we can do. And then another thing, I wonder, I'm going to save this. I wonder if we can think about some of the error things now as I'm kind of broadening my view. So I could say if value is greater than 127, then I could say string equals OX error, and I think I can just say return right here. And if I have that as a bad thing, or is it one vertical bar or two? I don't remember. Let's try it. Value. If value is greater than 127, if that's true, or if value is less than minus 128, because we're looking at an 8-bit signed value. Either of those cases, I want to return string as that, and I want to return an error. So I think that would take care of everything. Let me save that. So I've got my comments in there and stuff. So let's give it a shot here. So if I do hexify 8, let me make sure 13 behaves. Yep, hexify 8 of 127. Let me make sure that behaves. Yep, hexify 8 of 128. That's too much, isn't it? 28 plus 128. Yep, that's error. Yeah, baby. And then if I say hexify 8 of, let's say minus 1, what do I get? Yep, fox, that's right. Hexify 8 of minus 128. That should be okay. Yeah, that's an 8-0 hex. Hexify 8 of minus 129. Yep, that's error. So yeah, that's looking good. So maybe one of the last things we could do here is turn our debug on and then look at what the hexify 8 does for, say, 13. See what happens. So in the first loop, yeah, we do get the D, and after we shifted, our value is 0. And on the second loop, we get the, again, this is reverse string, so it'd be D0. Value is 0 again. It's left after you've shifted a second time 4 bits, and then you turn it around. You take the 0D, turn it around, you got OD. I'm sorry, you take the D0 and turn it around, you get the OD. So that was with debug on. Okay, in summary, we did a quick overview of the problem statement for Hexify, and then we talked a little bit about focusing on certain important things like the book and some of the videos and the lectures, and sort of spiraling out from there. And thought that was a very important discussion, maybe to get you to focus on the important things. And then we wrote our own Hexify for an 8-bit function based on just the bit and bit shift primarily. And we started with the bitify 8 function, and what we ended up with is easily extendable to 16, 32, and 64. We looked at how to add a debug feature to the functions, and I hope you've enjoyed it.